एक मिनट में लिख रहा हूँ किसकी नहीं आई। ढूंढो ना किसकी नहीं आई। आ जाओ आप आ जाओ। हाँ हाँ स्टार्ट करो मैडम। एक बार अब तो ये बोल लीजिए, मैं एक बार देख रहा हूँ, बस मैं ढूंढ रहा हूँ यहाँ पे।
Hello, good morning to all of you, and welcome to all in 83rd annual session of IRC hosted by Government of Chhattisgarh. We all are gathered here to discuss the new technology, material, equipment, software, machinery used in development of the road sector in our country. We now begin technical session 9, presentation by stakeholder. There are 11 technical presentation to be held under this session. So, session 9 will be start. Chairman of this technical session is Dr. N.C. Pal, former Engineer in Chief, Works Department, Government of Odisha. And the co-chairman of the session is Shri Rajiv Chhatra, Chief Engineer, NHPWD, Government of West Bengal. बहुत बहुत स्वागत है सर आप दोनों का ही। चेयरमैन एंड को चेयरमैन को मैं आमंत्रित करना चाहूंगी मंच पर इस सेशन की विधिवत शुरुआत के लिए। डॉक्टर एन.सी. पाल और श्री राजीव छत्रा जी, जोरदार स्वागत के साथ मंच पर हम अभिनंदन करते हैं, आभार व्यक्त करते हैं। आप अपना महत्वपूर्ण कीमती वक्त हमारे साथ साझा कर रहे हैं सर, बहुत धन्यवाद, बहुत शुक्रिया। और साथ ही साथ अब मैं चेयरमैन और को चेयरमैन के स्वागत के लिए श्री बी एस बघेल जी से रिक्वेस्ट करूंगी, चीफ इंजीनियर ऑफ पीडब्ल्यूडी दुर्ग छत्तीसगढ़, की वो मंच पर आए और इस कार्यक्रम की विधिवत शुरुआत करने में एक कदम आगे बढ़ाते हुए हमारे दोनों ही चेयरमैन और को चेयरमैन का स्वागत करेंगे। थैंक यू सर। और 10-10 मिनट का प्रेजेंटेशन होना है। प्रेजेंटेशन के लिए कौन कौन स्टेज पर आमंत्रित किया जा रहा है, मैं सबसे पहले बुलाना चाहूंगी Epoxy Asphalt Modified Binder by Chemical System, California, USA, an overlay system of durable and smooth riding payments for bridge, rigid and flexible payments by Mr. Mridul Goyal, SSPI Industrial Product LLP, महाराष्ट्र। जोरदार तालियों के साथ स्वागत आपको मंच पर बुलाना चाहते हैं सर। इसके अलावा 21st Century Full Spectrum Automated Road Condition Assessment and Evaluation from Opinion, the Factual State of the Art by Mr. Clint Bradley, Global Business Development Manager, Automated Road Rehabilitation Business System India Private Limited, उत्तर प्रदेश। जोरदार तालियों के साथ स्वागत करेंगे सर आपका। साथ ही साथ गार्ड मेकिंग फ्लेक्सिबल जियो हजार्ड प्रोटेक्शन सिस्टम स्मार्ट बाय मिस्टर रजनीश नाथ, जियोब्रग इंडिया प्राइवेट लिमिटेड, गुड़गांव। स्वागत है सर आपका भी। Reinforced soil technology and sustainable tunnel portal platform construction in a complex Himalayan geological city by Mr. Patanu Adhikari, Chief Development Officer, Reinforced Earth India Private Limited, New Delhi. बहुत बहुत स्वागत है सर। नेक्स्ट जनरेशन टेक्नोलॉजी रोड इंफ्रास्ट्रक्चर एंड डेटा यूटिलाइजेशन बाय मिस्टर रिचर्ड विक्सबैंग, इंडियन रोड सर्वे एंड मैनेजमेंट प्राइवेट लिमिटेड। भाई देखिए, ये होती है एनर्जी, ये होती है ऊर्जा, जिस तरह से अंदाज से स्वागत कर रहे हैं। आप लोगों को क्या हुआ है? इतनी गड़गड़ाहट होनी चाहिए कि ये जो धरती है वो कँपने लगे। इसी उम्मीद के साथ मैं अगले गेस्ट को बुलाने जा रही हूँ। Hot in place recycling HIPR technology for periodic renewal of bituminous concrete by Mr. H.K. Sehgal, Chief Operations TRPL India Private Limited, Bangalore. Stabilization technology using stable road additive by Mr. Krishna Remela, Direct Eco Additives, Vishwa Samudra Engineering Private Limited, Hyderabad. मैं बुलाना चाहूंगी एडवांसमेंट इन रोड सेफ्टी एंड एनडीटी टेक्निक्स फॉर कंक्रीट ब्रिजेस मिस्टर परमीत सिंह अर्नीजा डायरेक्टर Nivantek इंजीनियर कंसोर्टियम प्राइवेट लिमिटेड न्यू दिल्ली। सर स्वागत है आपका भी मंच पर। इसके अलावा लेटेस्ट डेवलपमेंट्स इन पीएमवी टेक्नोलॉजी हाई वीडियल एसपीएस पॉलीमर्स बाय मिस्टर विटर जोन्स नीदरलैंड Carton Polymers India Private Limited. Affordable civil and road design solution introducing bricks CAD and civil site design by Mr. Shubham Anil Vani, application engineer civil survey applications. जोरदार स्वागत है सर आपका भी। Underwater retrofitting and straightening of bridge by Mr. Rajesh Pandey, Dinosaur Concrete Treatment Private Limited, Varanasi. जोरदार तालियों के साथ स्वागत करेंगे सभी का और बहुत बहुत धन्यवाद, बहुत बहुत शुक्रिया। और चेयरमैन और को चेयरमैन से may I now request the chairman or co-chairman to come on the start the session. Please kindly conduct the session and over to you, sir. Thank you.
Good morning to all of you, and thanks IRC for giving an opportunity to chair this important session on new material, new technology, and more importantly, the new advanced equipment for mostly non-destructive assessment of road and bridges, which is very important. And globally, there are a lot of progress in our country also at national level, at state level. Many of the states have already adopted many of the systems. So I'll touch upon some of the issues that may come in between the presentation I expect. And I'll also request my co-chair at the end of the session to little bit give a wrap up. Since the time has been allotted initially from 11:15 to 1:30, I think we are now about half an hour delayed. Still then we'll try to encourage out of 10 minutes presentation, minimum 8 minutes presentation to each of the presenter. We'll see the presentation and maybe at the end of all presentation, we'll allow for interactions. Though I would have preferred in between interaction, but because of the time, we'll see during the progress. So before that, as a responsibility of a chairman, let me give my opening remark on this topic that has been selected for this session. So there are 2-3 broad area. Being the expert member of the material accreditation committee, we used to evaluate all the new materials that are coming up before the committee for use in our bridges and roads. One of the first presentation possibly focus on that epoxy related modified bitumen or concrete technology for road and bridge wearing coat protective layers type of and for riding quality related issues. So this is one of the emerging area where many times from CC wearing coat to mastic asphalt BC combination to the new technology based materials to improve riding quality of the road, particularly bituminous or concrete, but more importantly for the bridges. Many times we have seen when there is an issue in the wearing coat of the bridges, some of the state and some of the engineer and some of the vendor go on overlapping on those wearing coat in place of removing the existing wearing coat. When they go on adding the dead load on the structure, that became critical to the stability of the structure. So what are the best issues that the existing wearing coat, whether the CC or mastic or something else can be removed, or the new material which is to be applied? What is the reversibility of that new material, when it can be issued, removed and can be reused? Maybe those are the things that are the emerging area when you see a bridge from the riding quality and wearing criteria condition, not on the structural damage underneath the deck or underneath the foundation. That is one of the very important area. In addition to that, there are non-destructive assessment equipments available for condition assessment of bridge. Many common equipment that we read 30 years back, maybe ultrasonic and rebound hammer, corrosion observation system, they are all old, obsolete. There are now technology which are available including patented software, so that the moment you do certain NDT at the site, your software can capture that on a web-based applications. And I have seen some of the presentation from the Switzerland and other agencies, so that at the time your testing at the site is over, you have already captured those data, what have been tested at the site. So then you can go on interpreting those data and decide your rehabilitation or retrofitting strategy of the bridges. That is one area. Some presentation are concerned to that. But more importantly, on the road sector, the common equipment that you use is a network survey vehicle. Maybe last 10 years, I belong to state of Odisha. From 2013 onwards, we have used taking assistant of Central Road Research Institute. The ARRB Hawkeye NSB initial, then slowly other industry-based and whatever available in our country, all type of network survey vehicle. Many of you who are attending here, maybe the network survey vehicle in one go give you the most of the important functional criteria like the roughness related data, the pothole, rotting, leveling, cracks, all those things. But the structural data, again, you have to run another equipment, we called it falling weight deflectometer. You have to go second time. Based on the condition index or the payment condition index of the initial data that you have captured from the roughness and the distress parameter from the distress index, our IRC 82-2023 has come out very clearly how to quantify the payment condition index in certain number. Then on the basis of that PCI number, we have decided which stretch has to go for further structural evaluation. Then we send another team of people with the falling weight deflectometer who capture the falling weight deflection to find out the bowel and the structural strength of the layer. And then the third thing that is important to know the quality of work or to know the layer thickness for back calculations of the module and to find out what is the additional overlay that will be required. Again, you go on excavating some of the part of the road to know what are the layer thickness, some sort of destructive thing, and a semi-destructive is maybe use of a GPR. But many times we have seen the result of GPR are very catastrophic. They are not validated at the site when you excavate it. Many times, about 10 years back, I've given a suggestion to CRRA. Why not you integrate all these three, NSB with FWD and GPR, so that in one go of the vehicle on the road, I will capture all this data so that my team at the back can do the analysis to find out the treatment criteria and the priorities of the rehabilitation or overlay, whatever required for that road. I believe some of the equipment has already come out, particularly ARRB I have seen in the technical extension stall. Many are being used abroad in China, Brazil, and other countries, not in India. I expect that those type of integrated equipment feature with NSB, FWD, and GPR will come soon. This is one area, maybe there will be some of the presentation. But more importantly, me and Professor Veer Raghavan, being in IRC S6 Maintenance Management Committee, we used to discuss many times if on a particular road, let me complete. I am a chairman, don't intervene, gentlemen. Let me focus on the issue. I am chairing, not you. I know what's the time. The third issue that is more important, the gentleman intervene, that is more important is that we have seen that on a road, if you send two different vehicles, two different FWD or two different NSB on the same stretch, subsequently within 24 hours, the data are completely different. So how to get rid of those issues? So these are three or more focus issues that maybe some of the presentation will concentrate, or may I expect that their presentation will have some of these slides, and maybe when you open this to the discussion to the forum, those issues will be discussed. So with this opening remark as a chairman, I welcome all the presentators. They are very renowned presentators with me. So I welcome the first presenter on epoxy asphalt modified binder presentation. Yeah. Actually, Mr. Mridal Goyal, SSPI Industry Limited. So your duration of time is 10 minutes. You can go. Around 7 to 8 minutes, I will give a first bell call. So let us welcome Mr. Goyal with a clapping of hands and we'll start his presentation. Thank you.
Thank you. A very good morning to the dignitaries on the dais. Thank you, Chairman sir. Thank you, ladies and gentlemen. A very good morning, and would like to give my appreciation to IRC for providing us this opportunity to present this topic of epoxy asphalt binder. So the way we have structured the presentation is that I'll be giving you a brief background about what the product is, from where this product originates, and then subsequently the force behind this product, Mr. John Bores, who's standing right next door, would take over and take this forward. So, epoxy asphalt binder. So just a brief background, I represent a company called Structural Specialities. We are based out of Mumbai. Three primary businesses we dwell into. One is the structural repair, rehabilitation of bridges. The second is the waterproofing business, where we do tunnels, we do bridges, we do all kind of structures. And the third is the material company, which is the company of interest in this particular forum, where we talk about epoxy asphalt, we talk about other products which interest the road network. So about Chemco Systems. Chemco Systems is a company which is almost 5 decades old. It is based out of California in USA, and they, apart from epoxy asphalt, they are also into cryogenic insulations. They are into specialty epoxies and many other products such as high reflective pavement markings. So the epoxy asphalt was originally discovered by Shell almost five and a half decades ago. And subsequently, the IP was bought over from Shell by Chemco. Epoxy asphalt has numerous advantages, which John will talk about, but it is one of the most durable binders known to the humankind. It is extremely well proven technology. There are examples of epoxy asphalt being used almost 50 years ago. There are bridges in US, there are pavements in road network in New Zealand, which have been in existence for more than 5 decades. We are bringing it in India for the first time. We have some references, and we'll talk about all of that. I'll now give the mic to John, who will take this further. John, please come.
Thank you. Good morning, Mridal. I'm very happy to represent Chemco Systems here in front of the conference and the esteemed panel at the IRC. It was mentioned that we're talking about new technology, but this technology has been around for 60 years. We've made it a little bit better over the years. We've continually improved it. But I have one cautionary statement for everyone. Please don't consider buying, employing this technology unless you are ready for a roadway, a taxiway, bridge deck to last many decades without replacing the surface. Epoxy asphalt is very unique. It is a mixture of bituminous components and a three-dimensional polymer that's based on epoxy resins and very flexible curing agents that provide incredible performance to the neat bind. When we use it, we always have at least two components. One component is the epoxy resin blend, and the other component is asphalt in combination with curing agents, conditioning agents, and materials that allow compatibility with various aggregates. Pretty much every other type of flexible paving uses a binder, whether it's a standard binder that comes straight from a refinery or a polymer modified binder that melts. These binders are all thermoplastics. Our product is not. You can take our product and if you're looking at the neat binder, stick it on a hot plate at 300 degrees Celsius, it stays a solid. That is one of the prime distinctions of our product versus all the other binders used in the flexible pavements. Murdo mentioned this already. The original patents for epoxy asphalt were published in the late 1950s and early 1960s by Shell, who essentially decided somewhere in the mid 1960s that they were never going to sell 3 trillion tons of this product. It was too specialized. And that's when our predecessor company purchased the technology from Shell, and we've been developing it ever since. The first use on a bridge deck was in the San Francisco Bay Area. And oops, sorry about that. And that surfacing lasted a very long time without any maintenance and was finally replaced after more than 4 decades, nearly 5 decades. We are currently driving on this product when we go across the Golden Gate Bridge. And it's almost 40 years old and probably needs to be replaced, but this is the history of our pavement. We have a bridge in Southern California that's now got a 54-year-old epoxy asphalt surface that was placed in 1970. How many people in this room have a career that's 54 years old? Not too many. Here's a quick history. There's a little bit of inaccuracy on this, but our first project in Asia was in Nanjing, China in 2000. Yeah. So it stood the test of time. In China, it's still in service at 24 years on that second Nanjing Bridge. So a quick summary of some of the benefits. Its primary characteristic, which actually isn't listed on this slide, is helpful on bridge decks that have deflection based on the flexible steel, orthotropic steel decks, which are now employed in this country, in India, on the Trans Harbor Bridge in Mumbai. And that is one of the severe tests for any type of pavement when there's a bit of deflection. And that's where the outstanding fatigue properties of epoxy asphalt come into play. Is that yours?
No, that's a big deal.
Where can you use it if you want a long-lasting pavement? Its history has primarily been on bridge decks because that's a very strategic road that's very costly to close. But it's now more recently becoming of interest with the concerns about sustainability around the world in on-grade surfaces. It's been used in taxis and taxiways and runways and airports, in port conditions, ocean ports, and in some countries are far along in their analysis of using this product in on-grade, open graded, SMA, and dense graded applications. Just a quick comparison between conventional binders. This lists two common products used in India. The VG40, which is unmodified, straight from the bottom of a vacuum tower. A PG grade that's SBS modified, and typical performance for epoxy asphalt. The numbers that are listed for epoxy asphalt are not just ours. These have been validated by CRRI. a summary of the table that was on the previous slide is here. You can see the incredible Marshall stability, which is a big distinguisher. I'll leave this back to Murdo.
Yeah. So, a quick 2-minute video of the work that we have done for Mumbai Pune Expressway. Just 2 minutes. There are many benefits that has been talked about, but give you a it has an extended lifespan, almost 6 times longer than a conventional pavement, almost zero maintenance, ideal for very, very high trafficked areas. It's eco-friendly, it maintains the skid numbers that we want, and this is not a statement made by us, but by a multilateral agency, OECD, which studied this particular product over many, many countries. And they said epoxy asphalt has demonstrated its ability to deliver such long service life as a pavement, superior qualities on performance, such as stiffness and resistance to rutting, fatigue cracking, and abrasion. So, and it's very, very less susceptibility to water damage. So this is in brief the presentation. We have a stall, we have a booth in the Titagarh Hall, and if anybody wants more information, they can please come and seek that information.
Okay,
Thank you,
thank
sir.
you.
Thank
Thank
you
you,
so much.
Mr. Goel and Mr. John, who presented nicely. Now, the second presentation by Mr. Bradley on 21st century full spectrum automated road condition assessment system.
She's not getting over. ये वर्किंग नहीं होते.
What's the problem? Is there any problem in his presentation?
कुछ नहीं हो रहा. प्रिंसिपल नहीं हो रहा है. ये प्रिंसिपल वर्ष का होगा.
There is some security alert to the system. Can you go for the next presentation, Mr. Bradley?
No, it's hang. The system.
It's hang, huh? System hang.
Or can we bring another laptop?
That's the IRC organizer system or his own laptop?
No, no, IRC is the laptop hang.
कहाँ गए हमारा इवेंट मैनेजमेंट? ऐसा लैपटॉप क्यों रखते हो ऐसा प्रेजेंटेशन में?
यहाँ पे लगा. सर किसी पे रखते हैं.
I think it has come, huh?
How about that? Right. Technical difficulties. So, good afternoon, ladies and gentlemen, colleagues and friends. My name is Clint Bradley. I'm the Global Business Development Manager for ARB Systems. What I wanted to talk about today was the effectiveness and how essential it is to collect a comprehensive data set to manage your road network. Incredible India, an unprecedented pace of new road development. India is certainly leading the world in this regard. But it's no use building all these assets. You have to get the full value out of it, you have to maximize its useful life. Now, how do you do that? By collecting comprehensive data sets and using them smartly. And you do that through using a road asset management system. What does a well-maintained road network look like? Well, in general, you're going to have less than 10% in the poor and very poor condition category. The idea behind the maintenance budgets should be to preserve those roads and keep them in fair condition, stop them falling into those lower categories of road. Now, a well-maintained road is also a safer road. India's fatality rate on the roads is appalling. It's about 10% of the entire world road fatalities. That has to stop. That's while I'm standing here, just briefly, on average, there's going to be more than 2 people killed on Indian roads. What does an efficient and effective asset management system look like? How do you make the right decisions? How do you do it at the right time? How do you get it right? The cornerstone of that is good data. You have to collect condition data, it has to be accurate, and it has to be full spectrum. How do we do that? With our Intelligent Pavement Assessment Vehicle, our iPave. It's the first fully integrated surface and subsurface road assessment vehicle in the world. So now you're getting functional and structural data at the same time. I won't go through all of this, but what you can see is a lot of you will be familiar with network survey vehicles, falling wake deflectometers. Essentially what this vehicle does is combines those data sets. Now you have your digital imaging system, you have your roughness running texture, you have all the laser profiler data, and you have the automatic crack detection as well. And what we do is we add into that the continuous deflection measurement. As you can see there on the slide, you can get equivalent deflection bowls, equivalent FWD, which most people are familiar with, but this still isn't comprehensive. What makes the iPave comprehensive is the addition of GPR, ground penetrating radar. We need that to get the layer thicknesses, non-destructive layer thicknesses. And we combine that in an integrated system. So traditionally you would have all this data combined through different methodologies. So you might have FWD, you might have a network survey vehicle, but these data, there are different resolutions. You've got a high resolution with NSV, and you've got very coarse data with FWD. So now we do that, we combine it, all combined together as one. All these different collection modules all come together, and we can use that within the software and make these decisions. What's an example of how we use this integrated data? You can see on the slide there, if you look at the top left, that road looks like it's in good condition. It looks smooth. It's it looks like it has good texture. It's not rutted. But we look into the data, and the first thing we do is look at the deflection data. And we find a spike there, and we go, okay, well, let's have another look, have a further look, and we start to see the beginnings of cracking forming. And, all right, that's a little unusual. Now that we have the GPR, we've solved the problem there, or we've solved the riddle. So we can see on the GPR that there's some moisture ingress there. So now we're able to make a decision, a maintenance decision, to repair that road more cost effectively now, rather than wait for it to fail. That's the power of the data. You can analyze this across networks in various different ways. But in terms of how powerful this data is, I just want you to focus on the bottom left graph. And you can see the amount of poor roads in this network in red over the first few surveys. So these are about 3 years apart, these surveys. The first 3 number in the poor category was dropping. And what happened about halfway through that survey, or those set of surveys? There was a change of government on this particular network and a change in attitude towards the maintenance budget. And what happened? Just in 3 years, the poor condition roads went back up substantially. Now, these traffic speed deflectometer devices, of which the iPave is one, the TSD component is the deflection component. They have been used throughout the world so far, but importantly, we've used them in Australia, we've used them in New Zealand quite extensively now, the US. But importantly, we now have experience in emerging economies, such as South Africa, such as Brazil. Now, I'm sure you've all looked to see what India's doing there, and it's in grey. That's changing. Start of next year, that is changing very soon. What it does, you talked about resolution earlier of data. Now you have network level data that you can use at a project level. So previously, you would have to go and basically run another project, right? Which is going to be more expensive. You're probably going to get falling wake deflectometer testing done, which is less safe as well. Now we can combine all that, and we can make these decisions using the one vehicle. Now you're probably thinking, righto, this vehicle's got some cool stuff on it. It's going to be expensive. And you'd be right, it is expensive. But it's false economy to go for cheaper modalities like visual inspections, FOD, and SV. Now, while it might be substantially more expensive per kilometre to collect with an iPave, you get that breadth of data. And through the decisions you can make, what we've found through economic analysis is that it saves about 10% on maintenance spending per month. So it more than pays for itself in smart decisions. Now, safety, as I mentioned earlier, is another big aspect of this. So the vehicle is IRAP accredited. It says Class B on there, but the last few days it actually became Class C, which is the highest level. And the beauty of it is you don't have to do that assessment straight away. You can use this data later, up to 12, 18 months later. So you have the opportunity to do that. And you do that through, as you can see on the right, your customized forms. You can do other inventory assessments that way as well. Now, using that safety assessments, as you can see now at the top right, this network has a high percentage in the low star, 1 and 2 star roads. So once you've done the star rating, it's important then you can make those decisions. You can go back and go, all right, what are the countermeasures we put in place? In this instance, those were done. And as you can see, there's a substantial improvement. Most of those 1 and 2 star roads have moved up into 3 star roads. They're much more safer. Nobody wants to see this anymore. The safer we can make our roads, the better for the whole community. In conclusion, the iPave is coming. We're ready. India's ready. And the people of India deserve the outcomes that the iPave can provide. Dhanyabad.
Thank you, Bradley, for an excellent presentation and in the stipulated time. Now, the third presentation is by Mr. Rajnish Nath, Workbook for India Private Limited, on GUARD Guard, making flexible geohazard protection system. Well done.
इसमें क्या कर दिया वो? ये वैसा ही होगा, ऐसे ही होगा, ये तो हाँ, लेकिन इसमें तो जीपीसी उसमें ठीक है, हम मैनेज करना चाहिए कुछ।
हो रहे थे तो इसका 12 मिनट हो रहा देखो इसका तो
2 मिनट खत्म, थोड़ा सेविंग हो गया, लेकिन बीच में खा गया मैंने।
तो उस प्रोजेक्ट का
उसमें जो है पहला प्रेजेंटेशन, उसमें वीडियो में ही सारी दुकान, और क्या है, और क्या चाहिए, ये सब कमर्शियल इसमें इंट्रोडक्शन ऑफ कमेंट नहीं देना चाहिए ना, मैं इनको कोई ट्राई टू टेक एडवांटेज ऑफ दिस ऑडियंस, क्या कर रहा है काम। फिर लैपटॉप चेंज कर रहे हैं, सिस्टम बैन हो रहा है, सिस्टम एक में एक लैपटॉप से एक ही चलेगा।
A very good afternoon to everyone. Thank you, Chair, and thank you, IRC, for giving us this opportunity to speak for a very important topic at the moment. Since we are all talking about technology, so technology has come to this level that everything is away on click of a mobile app button. So thinking of this, we, Geobrook, a Swiss company, a leading supplier of flexible protection system, hazard protection system, has innovated a product. For the last 10 years, we were working on this, and now we have come up with a product which is smartly saving the assets, like flexible barriers from any event through our guard device. and we call it smart because it is very much up to the time which we are living, and it is very user friendly. Talking about guard flexible systems, why we read this guard is because consider a situation wherein your barriers are placed up in the hilly roads where the accessibility to the site is not possible for operators, and considering the fact that you have to guarantee the functionality of these barriers, you need to send your operators for maintenance and inspection every time without knowing what exactly is happening up in the hill, what kind of mass movements are happening up there. So smart guard plays a role in that, a big role in that, to reduce the effort of human as well as make it safer for the operators. So I will cover these topics in my presentation. First of all, how it functions. Actually, this guard transmits signal to a cloud server, and from the server it goes to the management dashboard, wherein you can analyze every event which has happened to your asset. Primarily, three major functions are covered here. One is dynamic event, that is like rock fall happening over the barrier, or a tree impact, or a debris flow. So this dynamic impact is managed by acceleration sensor in the device, which notifies the uh, road authorities immediately about any high impact on the barrier through a SMS or an email. Or in case of low impact, this will be delivered to the management dashboard again in a week's time. Next important thing in case of barriers is the static load, like continuous buildup of debris through a hill scree, or a snow pressure in case of avalanche barrier. For that, we have one rope force sensor, which measures the movement and inform you in day and weeks. And the third important aspect is the corrosion, which is monitored through a corrosion sensor. This is more required if you are talking about predictive monitoring of your barriers. So for that, corrosion sensor is very important. Apart from all the three sensors which I said, there is also a few sensors for monitoring the environmental condition in which your barriers are operating, like temperature, humidity, and as well as the device health is monitored through these sensors. These guard usually communicate over a mobile network. You don't have to have a separate contract or satellite dispatching of the signals. It can be done over a mobile network. The most important thing which we evolved over a period of our research is the battery. You don't have to put a separate power bank or power source for this guard. So there is a battery which is inbuilt inside, and this battery can go on up to 7 to 10 years, and you don't have to charge it. Whereas other similar kind of devices, you will find a separate power source, a lot of wiring altogether, which makes the use of those kind of systems very difficult for the authorities. So as I said, dynamic impact is told within a few minutes. The durability point of view, it is more than IP67, so it's waterproof, even UV resistant and heat resistant, and the acceleration impact can be taken up to 200 G, which is a quite a huge value, and can be assembled on wire rope between 12 to 424 mm. This is how the history of development of this product. We started with first acceleration sensor for measuring the impact way back in 2010. Slowly, we added corrosion sensor in collaboration with InnoSwiss University, and then we had developed rope force measurement. And now all the three separate boxes are culminated into a single device, which is you can see on the right side, extreme right. What are the benefits? As I said, it will reduce the effort of authorities, public work departments to regularly site visit. Once they will visit only if they find there is a high impact on their barriers. Otherwise, they can leave it as it is. So it will be more safer, because only in case of high impact you will be reporting for a immediate visit to the site. Same goes with in case of slow filling, that is static load cases. It will reduce your efforts to visit the site. And of course, the corrosivity give you an advantage of predictive maintenance of your barriers. So in culmination, these are the 4 points which we already discussed. And one more thing is, since the events are logged, so you will get the data, which is very useful for you. Over the years, you will find different categories of data being found on your system, which can help you to identify what kind of mass movements are happening up in the hill in your barrier, so that it will help you to plan for the future. This is how the platform looks like. This is a dashboard of a guard. In it, you can see four places where the guards are installed by a operator, let's say a PWD. And if you want to go to a specific guard, you just click into it, and this is the particular location where the guard is installed. And you can see in the dashboard, the four parameters are mentioned. One is the temperature on the right in the violet line. On the top is the historical data, what is being happening over the period of 1 month. And this green, yellow, and pink buttons are for the corrosivity. And the bottom left, this is for the incident occurrences. They're like when the alert happened and how you responded to you. So this is very user-friendly kind of dashboard. And these are the microclimatic data which can be found on your system, like temperature, humidity, corrosion, orientation, and peak acceleration. Apart from this, there could be a situation when while you use the guard that every small incidents are being reported to your mailbox, and it will be spammed by a lot of messages. For that, we have given an option to keep a threshold value beyond which only you will be notified and you will be addressing the problem. Otherwise, all those below the threshold value, you don't have to address those events for both dynamic and static threshold.
Which means
So one more thing, most of the countries, you can see the certification level of our product. Experiences per se, I will.
Please conclude.
Yeah, I will just conclude. I think this video is not running. So this is how this acceleration sensors are working here on the right. And there's the slow filling of the snow barriers, and you have a rope post measurement on the top rope. So this is regarding our partnership with InnoSwiss. We verified all the corrosion sensors in alternating climate test as per ISO 9227. And we have installed more than 400 devices in world, including in India, 2 devices already installed. Few more we are already working on with railways. So I will just show you quickly so you can see the event happened on 1st July 2022, and this was the rock weight, and this was the recorded acceleration. So that gives you an idea how it happens. And this case is of corrosion sensors. So this barriers were installed near to sea line. You can see there are 3 levels of barriers with different corrosivity level. Like the bottom one, which is close to seaside, is having more corrosion than the top one. So this data analysis can be done using the guard system. So there's a use case from South Africa. So that's all from my side. Thank you for being
Thank you,
patient.
Rajnish, for excellent presentation of this rope sensor and combination of that on real-time data assessment and alerting the authority. Now, the next presentation by Atanu Adhikari on reinforced soil technology.
Trey Arme. So very good afternoon, uh, chairperson, respected co-chairperson, delegates on the dais, ladies and gentlemen. So very good afternoon. I'm going to present a case study on a project. I have to check which presentation they have saved. It's not there. Can you bring my laptop? I don't see where they have saved it. Ah, it's here. Okay. Got it. Got it. Got it. Got it. Can you open it? Okay. Now you have to display it. So this is a project for a tunnel approach in Jammu and Kashmir. It's called ZMORE. And it's a very prestigious project, and I'm very happy and honored to present on this celebration organized by Indian Road Congress. So the content will be covered into basically 5 phases on this presentation. I will start with a brief project overview as we are talking about technologies. So these high-end technologies has been already adopted, and I hope this case study will inspire more such kind of safe project to be built. So it will be converted into, as I said, 5-section project overview with approach road, where we have built about 3-kilometer long approach road using our technology on the valley side. You can see the retaining walls, very tall retaining walls that we have built starting from 10-meter to 30-meter height. And I'm going present those in the subsequent section. We have done, in fact, doing already slope stabilization, very challenging slope stabilization work. And also we have done a lot of rockfall protection barriers, like my colleague presented earlier. The second section is on a portal, which is not shown in the picture. It's a tunnel portal where we have built pure bridge abutments and some new technologies which have adopted for protection of erosion against high velocity stream. And then ventilation tunnel, as it was a long tunnel. So on the portal of the ventilation tunnel, we have built some structures. I will explain that in the later part. And then followed by some dump structures, because this is also a challenge today when you build tunnels, long tunnels, lot of mud that comes, and in the hilly terrain there is hardly any space to store them. So all these in one project, and that's why it makes it very interesting. You can see one of the dump structures just constructed below as highlighted in red color. So it's just an example. So just a brief, it's, as I said, it's 4.5-kilometer long approach followed by a west portal, as you can see is highlighted in red mark. And then one of the ventilation tunnel structure that we have built, and then the dump wall. I would like to thank you, our client, of course, NHIDCL, the main client, and of course our customer APCO. APCO Infrastructure, who has given awarded this project to us to propose these sustainable solutions, and without their support it would have been possible to build such a huge scale of project in such a difficult terrain. So we are actually responsible for the providing entire design, supply, and also installation activity, including commissioning of these structures. Just before going into each of this section, just to explain you a brief about the technology that we have adopted. So we have gone for slope. If you don't know, the slope means it's about 70-degree inclination, and sometimes it is a wall which is 80 to 85-degree angle. Depending on the availability of the ROW, which is a big challenge in today's construction in the hilly terrain. So we have adapted. We have gone for 70, we have gone for 80, we have gone for 85-degree. So wherever the space was available, we have adapted those solutions. And also we have gone for special technology like TerraLink kind of solution. Now it is already published in IRC Hill Road SP 48. Where in the hill you have hardly any space available, so we have adapted those technology. So just a brief about the technology, not going into much of the detail, but few specific highlights. The reinforcement that we have used, which is polymeric geostrap coated with LLDP. I am highlighting this because especially in the hills, you use mostly gravel. and we are using polyester as a main reinforcement. So you can imagine if you don't have a high quality coating, the damage can go very, very high, especially when you are using angular particle. So the high quality coating reinforcement, like this kind of reinforcement, gives a added advantage to construct in the hilly terrain. Again, we have gone for very flexible but very durable facing system, which is made of special steel galvanized of 8 and 10 bars, and of course the connection mechanism, which is mechanically connected, which gives a lot of advantage, especially in high seismic zone. So with this system, we have proposed all our solution and constructed lot of structures, and you can see the picture at the right hand side. The hill slope is really steep. It's almost 40 to 45 degree, some locations 50 degree. And we have built more than 2.7 kilometer long retaining structures, height ranging from 10 to 28 meter, as you can see in this table. Some of the quick pictures, just to give you an idea. As I've said, we have adapted on the right side corner. You can see where we have gone for 70 degree, 80 degree, depending on the availability of the ROW. These are some of the pictures during construction. One of the figure on the left side, you can see what I mean by showed wall, where you cannot excavate. You have a challenge in excavation in the hill, and people mostly to avoid that, they go on hillside, which creates more havoc, more risk in terms of landslide. So we constructed a lot of retaining structure in the valley side with minimum cutting by providing this hybrid solution called TerraLink. And in a convention, you can see you need a longer base width. And wherever it was feasible, we go for that large base. More than 121 location is probably 150 meter. These are the challenge landslides protection that we are doing currently under execution. We are using ground anchors more than 50 meter deep. Sometimes people challenge, you cannot drill, you cannot go deeper. Please come to the site. We'll show you how to execute such projects with 15 to 50 meter deep anchors. We have installed 2.5 kilometer long, more than 2.5 kilometer long rockfall barrier as a protection against rockfall measures. Small video just to give you an so these are the approaches. Of course, from far it looks like a conventional retaining wall, but it's actually using the same technology that I have shown you. So environmentally very friendly, because we are using actually only soil and hardly any concrete. There is no concrete at all in any of our structures. These are the rockfall barrier. So that's about the approach road, which is about 4.5 kilometer, where we have done so much of works. This is at the western portal, where there was a tunnel. You can see the tunnel, and just outside the tunnel there was a stream. So there was a bridge to be constructed. So instead of going for a conventional technology, we have adopted what we call tech abutment. It's a pure bridge abutment, and you can see the 33-meter span bridge on the below picture, which is resting on reinforced soil wall, and it's actually resting on the backfill. So we can design such kind of structures with a and also with a waterfront structure. Now there are so many questions asked about building reinforced soil wall in front of water bodies. This is a line example. It's actually not true. We can build waterfront structures and very safe waterfront structure. Of course, you have to design for those loading conditions. And then we have done the protection using our solution called Tech Rebattement. It's a concrete fill mattress system. In the hilly terrain, you have so much of boulders. You have a high risk of damage. So we have come up with a solution which can perform really well under such environmental condition. This is a small, again, video just to give you an overall view. So you can see the approach road and the abutment which we have constructed.
Please conclude.
Surely, sir. 2 more minutes. You can see the bridge abutment resting on reinforced soil wall. It's a 33-meter span. As I said, on the ventilation tunnel, it was on a mountain cliff, about a height of 50 meters. There was hardly any space to work. So we have created this platform by building our structures on this mountain. Also, we have built so many dump wall structures to store the muck in the project. And that's all about the my presentation. Just to conclude, first of all, I mean, we are talking about building safe reinforced soil structures in the hilly terrain. I think this is one of the example where in a greenfield project we can build safe structures. Most important takeaway is that we should be very balanced in doing cutting and filling. So most of the consultants who are present, who really avoid going on valley side, that this, you cannot build retaining structures in a steep slope. I think they should consider building more and more balance so that we don't cut our hills so much and make our road very safe. And also to conclude, that yeah, as a part of these projects, we feel very proud that we are building such safe roads for our country. Thank you very much, ladies and gentlemen.
Thank you.
And I would like
Thank
to
you.
thank you, our partner APCO, for their support.
Thank you, Atanu, for a nice presentation and particularly on reinforced soil abutment with bridge with cover condition. Now the next presenter is Mr. Richard on next generation technology infrastructure and data utilization. That's more important. Data utilization. Welcome, Mr. Richard.
That one. Yeah. Okay. All right. Good afternoon, Mr. Chairman, Co-Chairman, fellow presenters, and thank you to the ISC and to all of you to come and hear this presentation today. Okay. All right. I guess it's not often you get two Australians on the same program here in India, but it looks like we're good to go. So my name's Richard Wicks. I look after the infrastructure measurement, or the team leader for that, for the National Transport Research Organisation. And my key is not working. Okay, all right. Well, I've already introduced myself, and namaste. Nice to be here to talk to you. So just a couple of minutes on the NTRO, the National Transport Research Organisation. We were born in 1960. We were formerly known as the Australian Road Research Board, but in the last couple of years, most of the road agencies are transformed into transport agencies in Australia. So now we're looking at more than just roads, we're looking at rail, ports, airports, as well as the roads as well. So we bring that heritage, though, of the Australian Road Research Board back to the 1960s. So over 60 years of history. Who own us? Well, we're a not-for-profit government-owned entity. So the different road agencies in Australia are our owners. So we're a research not-for-profit organisation. And we're also part of a global network of research organisations. You've got TRL in the UK, BAST in Germany. And excitingly, the exciting news here for India is we'll soon have CRRI as a partner in that global T7 as well. So we look forward to welcoming them on board this global network. And of course, it'd be remiss of me not to say that here in India, we work very closely with the Indian Road Survey Management
company, which we've done for the past 15 years. So just talking a little bit about asset management, we're not going to go into too much depth today. We know that if you're going to look after an asset, you need to know something about it. So if you don't do anything, it's just going to deteriorate. So you need to monitor its performance over time. So we have a bit of a saying, if you don't measure it, you can't manage it. So we need to be able to manage our road network in particular to be able to get the maximum life out of it. And I'm sure we all agree with that. So like here in India and in Australia and elsewhere around the world, we often look at the functional parameters. We look at what's happening on the surface of the road. We're looking at the roughness, the rutting and the cracking, texture, things like that. It's not too different from country to country. They're important factors that we need to monitor. So if we cover that, that's good, but it's even better if we know what the structural condition of the pavement as well is. So there's various ways we can measure the condition of the pavement structurally, especially deflection. So I guess what I'm trying to highlight here is that technology changes. So if we go back in time, if we were looking at the strength of the pavement, we're going to use something like this as a Benkelman beam. I'm sure people used here in India as well. It's pretty common. It was an easy way of measuring the deflection. But you know, technology moves on. Things change. So here in Australia, some smart person actually combined the Benkelman beam into a PACE, pavement assessment evaluation vehicle. So now we've got a moving Benkelman beam, of course, so it's no longer a static measurement, but here we're doing a whole 4 kilometres an hour. Or the one on the right is the fastest one in Australia. It does 6 kilometres an hour. So it still takes a lot of time to get around a network. Great for project level assessment. And of course, then, you know, most of us today, what do we use? If we want to know something about the structural condition of the pavement, we're going to jump in and we're going to use a falling weight deflectometer. Okay, here's a couple of examples. I know there's many used here in India as well. So that's a common measurement, but it's a static measurement. So it's hard to get a continuous measure of a pavement. And it's also has some other drawbacks in some ways. Some things to note, we got to have traffic control. That's important, but it's a cost. So there's economic and safety issues involved. We can't get around a whole 30,000 kilometre network with one FWD. You either need a lot of them or you've got to take a lot of time to do it. And of course, I just mentioned that the measurements are slow or static. Maybe they're a little like a snail in some. And there can be dangers too. So here's an example in India. This FWD has gone to rest. It's never going to drop another drop again. But fortunately, no one was injured in the accident. But that's the thing you want to deal with if you're doing static or slow moving measurements. So as technology has moved on, and we've already seen this in a presentation this morning, we're going to have a look at what can be done. But imagine this, if technology never changed. Now, I was over at CRRI just earlier in the week, and I saw an old bump integrator. So that was good in its day. That's what we use. But you can see we're doing only 30 kilometres an hour. Imagine if that's all we were using today to monitor our road network. As the chairman mentioned before, we have network survey vehicles. Now, there's a whole variety of them. Ursum has them, other companies have them here. So there was a leap in technology to be able to get much more than just the ride quality of the pavement as time moved on, and we get all these other parameters. And it's great because we've seen today already, that's what we've seen with structural and functional condition, is we've got our intelligent pavement assessment vehicle. So this was actually developed in Australia in 2014, was the first one that was built by the Australian Road Research Board. And since then, there's been many others. We no longer build equipment like that. That's something for ARB Systems, which is, if you're wondering, similar name, different company. It's the Australian Road Rehabilitation Bureau Systems, same acronym, but separate company. But we do work together often. So the iPave is a great way now for us to able to measure the surface condition and seeing what's happening under the pavement as well. So that technology is caught up to be able to give us that added information that we need to make more informed decisions on the condition of our pavement, to monitor it better, to get best use out of the money that we spend on maintenance. So it's the device of choice now for all our road or transport agencies in Australia. all of them. There's a bit of a gap in the middle there, but we're now actually doing South Australia as we speak. So 100% of the Australian state highway network is covered with the iPave, and it's been doing that since 2014. And not to forget our neighbours over to the east in New Zealand are using it as well. And most of the states do this on either every 1 or 2 years program. Now, just a little bit about Australia, like some other countries where either it gets really hot and we get fires, or it can rain a lot too. And we don't really build the resilience into our pavements a lot. Back in 2022 in Victoria, the state I come from, we had a big downpour. I think it was like 200 millimeters in a night. Might be common for some Asian countries, not for us. You can see our road network is not really the same as it was before the rainfall. So what are we going to do about it? Well, we needed to get a lot of grant funding to be able to fix that road, but we were engaged to use the iPave to actually look at the structural and condition, the functional condition, the surface characteristics to determine how much the network had deteriorated because of the flood work. So we had historical data from 2021. We had it from 2022. We were able to see what the standard sort of deterioration between those 2 years was like. Then we compared it to 2023, later 2022 data, and we could actually locate, because they had us do 8,000 kilometres of the network which were affected. We're able to identify just over 700 to 800 kilometres, or 707 it says there on the slide, that actually had been affected by the flooding itself. So they were able to get some grant funding for that. Another example how you can use this data is comes from New Zealand this time in 2016 in November. They had a big earthquake, and what happened, that red route you see there is the National State Highway 1. There were some landslides, so maybe we needed some of the products we've been talking about here today to stop all the landslides going over the road. So they had to divert the traffic. And so you can see there, it's up to the top, little pink thing. So it's gone from orange, the regional road, to a secondary collector, to an arterial road, and then down to primary collector. So the truck volumes increased by about threefold. The traffic volumes were increased threefold over this road network that wasn't designed to carry that much traffic, but because it had this structural information, the functional information, they're able to actually implement some works to strengthen up that network so it wasn't destroyed by the extra traffic that was going over it. So a great way, an example of showing having this information can benefit the road or the transport agency. Now just a couple more slides here. The other thing is data consistency. We have 4 of those iPave units that we run around. We don't want to make sure things, the data out of them is the same, whether it's measuring the structural information or the roughness or rutting. So
Let's conclude.
Okay. So we can see, one vehicle might have, these are the results over a kilometre. Another vehicle, hey, that's great, be like this. But what we want to avoid is having a third person or a third entity come in and then measure things that aren't incorrect, that are incorrect. So we have a lot of test methods and standards that we apply to make sure that the data is collected accordingly to minimize this from happening. And this is my final slide. So think about it this way. You might have a cricket bat. 5 people might have a cricket bat, but do they all put it to the right use? Who would you give it to? This man? Or are you going to give it to here? No, Venkatesh Prasad, no slight on him, but he wasn't the greatest run scorer now, was he? So you've got the equipment, you need to be able to use it properly. And so just something to keep in mind there. So things to remember in conclusion, we've got a device now that can cover whole networks, as we've seen and discussed already today. It's continuous data, so it's not point by point. We get a better understanding of the network by knowing what's happening on the top and what's happening on the bottom. Leads to a more evidence-based decision-making. Get better value for money, and it's certainly our goal is to help bring this technology here to India too, so you can benefit from it. Okay, Bahut Dhanyavad.
Thank you, Richard. And more particularly for your last slide on data consistency. Now the next presenter, sir, is Mr. Sehgal. on hot in-place recycling, which is very important when you talk about RAP for periodic renewal and periodic maintenance of bituminous road.
It's not coming on then. Thank you, Chairman. And good afternoon, ladies and gentlemen. Yesterday, something interesting happened. Minister Gadkari apparently touched on 2 or 3 aspects of our presentation, specifically talking about waste to wealth and also talking about RAP. So that's what we are taking this. Oops. Where's the gentleman here? There's something else that's come across. So a plethora of presentations, rather circulars. Hey, what's this? Again, this is not moving. Move to the next one. Switch here.
देखो यही वाला है ना हाँ हाँ सर यहाँ से नहीं यहाँ से बढ़ेगा ना सर ये बढ़ेगा यहाँ से बढ़ेगी
Okay. Oh, कहाँ से? यहाँ से?
हाँ
Okay, fine.
you are already
Yeah, okay. So I'll move very quickly on the presentation. Some policy circulars and guidelines there. Hot in place recycling is a process for correcting asphalt pavements, surface distresses, using indirect gentle heat. Hot milling is, of course, provided with surface followed by in situ mixing of RAP. Now, this is something that Minister Gadkari talked about. And with proportionate virgin bitumen, paving the recycled road once again using the same RAP without shifting it from the road at all. So this train, as you see on the right, is about 80 meters long. Its recycling width is a lane by lane, and it has no traffic congestion. We've done something like about almost 1,500 lane kilometers over time, on bulk of it in South India. The lengths that we've executed are as much as that. Area is about 5.45 million square meters. Bitumen saved as 16,000 metric tons and aggregate conserved as about 3.15 lakh metric tons. Hot mix strips, naturally, they have been saved. And there is an aspect of CO2 emission reduction. Now, this is relatively new in India in the sense that the policy guideline and the law has been enacted only last year. But I guess this is going to take on more and more importance as we go along, because CO2, we are committed to, I think, 50% reduction by 2030 and zero by 47. So where does one recycle? These are the roads that one chooses with poor riding quality or raveling, rutting, other under stresses. And the core sampling and homogeneously grouped sections are then taken in for mixed design. Mixed design comprises of the usual Marshall process. I won't spend too much time on this. But once having done that, you heat the road. There's a heating process, and the heating process one recirculates the hot air in order to conserve on energy. And then we have the wrap, which is culled out of the road. And having culled that out, it's done lane by lane as we show you here. There is a mixing of rejuvenator. Having mixed the rejuvenator, we bring in fresh mix depending upon whatever is the Marshall testing that has been done and investigations done earlier. Essentially, the objective is to ensure no variability in the final mix. So continuous mixing with the wrap and fresh mix delivers the recycled mix with no variability. Laying process is typically conventional. Paving and rolling is also conventional, and something that was mentioned in the previous session. Yes, rolling is important, and so the more one rolls at the appropriate temperatures and with their appropriate pressures, you get better results. Post-construction audit follows every day. Sampling, extraction, gradation, recycle binder properties, Marshall properties, etc. Here and on, what I'll do is I'll have my colleague Preetham Bhaumik take over. But this is the iceberg effect, where we are talking about the bonding that comes across as a consequence of this hot-to-hot activity. So as wind moves, this can be applied for 30, 40, and 50 millimeter compacted thicknesses. But as one moves from from 30 to 40 to 50, while you are increasing the height from the FRL by every 4 interval, you are actually digging in deeper in terms of milling by a 6 millimeter interval, thereby getting rid of more distresses, resulting in this kind of a monolith bond. Preetham will take over from here.
Good afternoon, everybody. So, why we call this slide as an iceberg effect is whatever significance that is happening beneath the surface. So, instead of, increasing the FRL, if there is an incremental milling from 30 to 40 to 50 of the compacted layer, thereby, with the incremental milling, all your existing distresses are getting eliminated. And since you are heating the road, your entire top layer and up to some extent to the DBM layer, it is getting heated. Now, if it gets heated, the entire layer will get restructured. And if it's restructured and then we are milling it, and after milling, the milled surface is constantly heated. And once it's heated, you will see that the recycled layer, if you take core samples from the recycled layer, you will not able to see a parting line between the recycled layer and the layer of existing layer. So you will see a hot to hot monolith bond. Now the importance of hot to hot monolith bond is it will give you the strength, it will give the pavement the longevity that it needs. Also, it will, retards the formation of potholes in the road. There is the laboratory performance, by CRRI. We are in the very initial stage of this performance evaluation at CRRI. These are some of the, results tested on the initial, phase of the testing. And we get to see that the parameters that we are getting is superior to the conventional mix. So we can say that, hot and bliss recycling can provide a superior performance as compared to a conventional hot mix asphalt. Being a relatively stiffer mix, it is susceptible to, less rutting. It can resist rutting, wheel path rutting, or we call it as a functional rutting. Now, evidently, in one of our road, FWD tested by an independent engineer on both the sections. This road being, being around 180 kilometers long, it's allotted to one of the conventional party where they did 40 of conventional overlay. And some portions are also given to, for hot and bliss recycling as 50 So we did the hot and plus recycling at 60-40 ratio. We utilized 60% RAP and 40% virgin mix that we needed. The test that FWT test performed, it was shown that the modulus, the back calculated modulus coming out is better. I mean, although by marginal extent, the average back calculated modulus is better than the conventional overlay. Now, the point is raising the FRL by 40 mm in conventional, whereas the raising the FRL by only 20 mm in place of hot and plus recycling, giving us the superior strength as compared to conventional overlay. So here you are already saving, I mean, 30 mm of hot mix. And this is the thing we are looking into, because increasing the strength will increase the longevity, it will increase the durability of your road. Now, the bottom line is, as I already explained, that 50 mm or 40 mm thick HIPR is superior to a 50 mm conventional or 40 mm conventional, which is strengthening the wearing codes and it enhances your life cycle. Now, this study has also been, mentioned in federal highway associations by, our professor, Mr. Kandhar, in FSW chapter 18, where he mentioned that that the performance of hot and plus recycling is better than the conventional overlay. There's a surface riding quality tested at is NH65. The condition of the road is as intact as, as good as that one.
Please conclude.
Just 2 minutes, sir. Yeah, thank you. So in the second picture, you can see the HIPR that was done in 2013. It still lasted, till 2018. Now, we have delivered over 6 years of life. Now, when I say 6 years of life, 6 years of life until when the concessionaire has to overlay it because of contractual, conditions, but there was no blemish in the road. What are the outcomes? The outcomes is 100% RAP is reused. We are creating waste to wealth. There is no variability in the final recycle mix because of the heating process, because of hot milled and continuous mixing. We get a hot to hot monolith bond. Therefore, it will mitigate your pothole formation. It enhances the longevity of the wearing surface. So the important, the focus is there's the design engineers or, the DPR agencies. I would request DPR agencies here that the focus should be on the quality at the optimal cost and not just solely on the initial cost of the construction. Because at the end of the day, we are looking for a life cycle of the road. This is the resource conservation. So the cost effectiveness is maximum going to the nation, where we are saving almost, let's say if you take the ratio of 60 to 40%, 60% RAP and 40% fresh mix. So we are almost saving around 49-50,000 metric tons of aggregates, and bitumen, which means you don't have to mine your quarry, and also you don't have to produce that much of bitumen. Secondly, of course, there will be reduction in the haulages, reduction in hot mix truck trips, be saving your energy, saving your fuel. So what is RAP? RAP is basically, it's what the virgin material it is replacing. Some of the techno-commercial advantages that, that we deliver, or HIPR delivers to the NHAI or MORTH is, first is exuberance. There has been, we have been noticing that there has been a lot of exuberance in the bidding thing. So NHAI and MORTH is very much wary of this fact that most of the, in our fraternity, everybody is going very much low in terms of bid. Now, if recycling is allotted, it's been put as into the PBMC tenders, or let's say an O&M tenders. Basically, recycling is an laboratory intensive exercise. So whatever you are, putting it into the machine, it will come out after recycling into the same thing. So if you put a garbage will come out. So you have to be very much, cautious with respect to, whatever you are considering your points during the bidding.
Please conclude.
Yeah. Second is the quality, durability, and the conservation of natural resources, and the step towards carbon neutrality. The last thing is, what are the benefits for the concessionaire? They are getting a road which is which reduces their maintenance cost, which improves their longevity of the road. Recycling only the business end of the road. They can do the lane recycling. conservation of natural resources as it is, and reducing the carb height and soft shoulder filling. Thank you.
Thank you. The next presentation is by Krishna Ramela on stabilization technology, including certain stable road additive. Maybe stable road is the trademark of the material. Please focus on the technology and application only.
इसमें चला देखते नहीं होता है तो इसमें चला हाँ इसमें है ना फोल्डर डाल रेडी है एक्चुअली में ये कुछ हैंग कर रहा है हाँ तो ठीक है so this one कौन सा वाला I will remove this हमारा ये भी चाहिए वो वीडियो भी चलेगा स्पीकर ये देखिए कहाँ होती है मुझे वीडियो भी करना है स्पीकर भी लगा ये Where is the video? Want to add? Please be connected. एक मिनट तो चेक कर लो ये भी चलेगा ना ओके
Good afternoon, everyone. Welcome to all the dignitaries and my fellow colleagues from all across the industry. My name is Krishna Remela. I represent Stable Road and Visasamudra Engineering from Hyderabad. Visasamudra Engineering is a 6 years old company. Our chairman, Chinta Shashidhar, he was pioneer in the infrastructure and investments into the infrastructure field for the past 4 decades. And he started off this company, Visasamudra, after coming out of a big group. And he ran the Krishnapatnam port from a small fishing harbor, a small port at Nellore in the South India, to the second largest private port in India. And it's a feather in the cap for our organization. And slowly, as he has a dream of giving the environmental technologies to the country and to the world, we ventured into the worldwide market and then tried to identify the best technologies worldwide. And we nailed it down to Germans, because Germany is very good in technology and quality. So Stable Road is manufactured out of Germany and engineered out of Germany. And finally, we started off our journey at Krishnapatnam Port, where we had the highest number of traffic, where we have 3,000 trucks that are plying every day with high volumes of loads. And today, I think we have completed 8 years, and we have fantastic performance evaluations done by premier institutes across the country, the IITs, and also CRRI, and then the NITs across different states. And slowly from there, our journey started into state of Telangana, the city roads, Hyderabad city roads, followed by that to Kerala, where we have a maximum number of rainfall. And from there, we went into Punjab and then Northeast, all over the country. And today, I'm proud to tell you, we are the only one in the world, along with the Germans, they have done the defense installations, airports. We have done the entire stretch of Hyderabad main runway, that is 5 kilometers and 60 meters width. And this is the 4th year that's running. And the time we designed, the entire design was given in-house.
and the quality was also maintained in-house. The complete SOPs, procedures, everything was set by the Vishwasamudra team. And when we designed, it was 240 flights a day, and today we have 540 flights per day, and we're running successfully for the 4th year. And we are doing 4 national highways, 3 in Kerala and 1 in Jammu and Kashmir. And Kerala, we see the it's along the coastline. We have a lot of rainfall over there, and I'm proud to let you know that Stable Road actually they are into 2 different segments: soil stabilization, full depth recycling. Soil stabilization being the greenfield roads, and full depth reclamation is for the distressed payments. And why stabilization? It's all mechanized, fast pace. It gives perpetual payment, meaning the payment lasts for 10, 20, 30, 40 years. It's a longer life, and it works in different weather conditions across India. And in fact, we were the ones who, when the ministry approached, we had meetings with Gadkari ji and then General VK Singh that time. And we were offered to do some good infrastructure where we have very bad weather conditions. So we picked up in Andaman, and we were the ones who told, let's not get, at one point of time, they were supposed to get around 400 crores worth of aggregate from mainland into Andamans, and we told them not to take any aggregate. And we did around 80 kilometers over there. It is the 5th monsoon cycle, and it falls in the middle and northern Andaman. So we have around 9 months rainfall, extensive rainfall over there. And we also did in northeast in the state of Manipur as well as Arunachal Pradesh, where we had landslides and other difficult terrains, and it's working fantastic. And today we have also done the Goa International Airport for the perimeter roads as well as the parking lots. And why Stable Road? Stable Road is manufactured out of 100% natural minerals, and this has been there for decades. And over the years, the scientists, the owners have built it with a great performance track record. And if you see the difference, stabilization just with cement versus cement plus the additive being the Stable Road, you see those red colored this thing. It's all the CSH gels. So what it does is it densifies, and it totally, completely occupies into the micro structure, changes a lot. The bonding properties increases, and the pores are confined, and it densifies so that it's water resistant, acid resistant, oil resistant, salt resistant. So even in the sea saline area in the sea coast, it can be used in different segments. And we have a lot of international validations from and approvals from different reputed institutes. And these are some of the picks I just like to give you. And regarding the carbon emissions, I would like to give you one fantastic, numbers. We are the ones who are the gateway openers for the entire Indian community. Uttar Pradesh have started, they have done 4 visits. Uttar Pradesh and several state PWDs across India, and then the NHI teams have visited Krishnapatnam Port, the Hyderabad City Road, and even the rural roads in Andhra Pradesh, where we have done around 1,300 lane kilometers. And that time, when the entire team has come, we have opened up the gate for the entire country. And today, I'm proud to tell you, Uttar Pradesh alone have saved around 70 million liters of fuel, and they have saved 6 lakh truckloads of aggregate. Earlier, you can see the carbon emissions, reduction of carbon emissions. The aim is to get to zero emissions of our Honorable Prime Minister Narendra Modi ji's targets. Some case studies, these are the Krishnapatnam Port pictures. These are the cores extracted after 8 years. These are completely made out of soil. The Morram, there is no aggregate, 0% aggregate. The strength also increases every year. So the gist of it is like we climbed a mountain at a slow pace around in a 15-degree angle, and we'll never see the valley at all. So this is the Hyderabad International Airport. We have done in a record time of 40 days, and the PCN value was supposed to be more than 71, and we attained 108. And recently, IRSM has done the studies, and then I'm proud to tell you how even after 4 years, we still maintain and retain 118 number PCN. And these are the cores, and then these are the Andaman pictures. This is Bihar. This is the NH project, World Bank project. Every year, 2 months, these roads are submerged underwater, but still it's performing fantastic. Government of India under Azad Mahotsav, they have visited these roads and then they have appreciated. This is the code that was taken after the submergence. And you can see here, you can have the big bats also. We can use a lot of materials. These are the national highways we are done, being done in Kerala. This is again a 7-year-old state of Kerala PWD. These are Hyderabad roads. You can see on the right side how the contaminated water eats up the complete cement portion, but our portion on the left side stays intact. The gentleman is Mr. Shashank Mishra, IAS, MPRDC MD. He came on a personal visit. So you can see the gush of water during cyclones. The vehicle on the top. The officials realized there is no culvert, but still due to the slab action, it retains. Even a concrete road with a tin white topping can be laid on top of the stabilized base. These are some of the pictures when there is a drain failure, the shoulders failed, but still the road was intact. This is how the road even stands when there is a water pipeline broke down, okay? And I will play some video of the Hyderabad International Airport.
Thank you, Mr. Amela, for your
Yeah.
nice presentation.
Thank you,
And
sir.
the time is
One
over.
more
Thank
thing,
you.
sir. We fit into the seaports, airports, and state PWDs and the national highways. And also, we have done a landmark project in the US consulate, the largest campus in Hyderabad for the walkway. When they wanted to make use of the made in USA product, but they have got several products from USA and world over, but still our German product prevailed, and then we fit into
Okay.
the several
Thank you. Thank you.
categories.
Thank you.
Thank you so much for giving me this opportunity, sir. Thank
The next presentation is on two subjects, advanced road safety as well as NDT technique of concrete bridges by Parampreet Singh. He has combined two domains in one presentation. I will request Mr. Parampreet if you can complete within 8 minutes, because we are running out of time.
Are we getting the video, the presentation? Okay, great. So there are a lot of slides. So, and we are close to lunch. So hopefully I can keep you awake. There are a lot of slides, about 200, but many of them are pictures. I'll be speaking less and the pictures will do the talking more. So I'm going to take up two very diverse subjects. One is advancements in road safety and in NDT techniques for concrete bridges. So my company name is Avantech, and we have been serving our customers for the last 25 years. We do a lot of different verticals, advanced test systems, testing and consulting services, geotechnical and geological modeling software, and road safety systems. Discussing the testing and consulting and road safety systems today. Customers spread across India. We are an ISO 9001 certified. Advancements in road safety. Talking about a new concept called crash cushions. So I'll need your attention here. Crash barriers, all of us are aware, but now we are moving more towards performance tested barriers. And terminals, motorcycle protection systems. Our country has a lot of two-wheelers, so we need to focus on the safety of the two-wheeler rider also. So we'll be focusing a little bit on that. Bridge parapets, movable or median opening barriers, truck mounted attenuators, crash cushions or impact attenuators. So these are some of the hazards or gore areas that we have to be, which cause very, very severe accidents, and they cannot be protected using a crash barrier. So what we need is a crash cushion that goes in front of this. I'll give you some example. So this is what happens, what harm can a rigid object or a gore area do? So you can see it's quite a large vehicle. And even at 50 kilometers an hour, what it can do to the driver is quite severe. And then we'll see what happens with 70 kilometers per hour and then 100 kilometers an hour. So at 70, so many times with the new vehicles, when we're driving at 70, sometimes even within the urban areas, we don't realize we're at 70, but 70 can be quite a fast speed, and an impact with a gore area can be fatal. And at 90, there is no chance of a survival here, even with the seat belts on. So now the energy in a crash is a lot. So we cannot take it lightly, so it is like typically 770 joules is like if you take a 1500 kg car and drop it from a 10-story building. So that's the kind of energy we're talking about. So it cannot be prevented by keeping a sand barrier one or two here and there. And this is what happens. This is quite a common unfortunate sight. So the solution is the impact attenuators or crash cushions. So what it does, you will see is now this car is a heavy car, and at 100 kilometers an hour, and you can see that even the windscreen is intact. So these are what we call as a self-restoring crash cushions. And self-restoring crash cushions, they do not require, most of the times they don't require any repair. And they will come back to its original position and ready for the next impact. They've been tested from the front, offset, from the sides, side impacts, everywhere. So these are MASH compliant. So these are some of the installations of the React crash cushion. Then the other types are repairable crash cushions, where we have cartridges that need to be replaced. So here the crash cushion does not come back, but there are, special sacrificial components inside. So you need to pull back the crash cushion and replace the sacrificial component inside. But these are equally safe. The only thing is that you'll need to, set aside funds for repairs and set aside a team that will be responsible for repairs. Similarly, another crash cushion, another type. So these are some installations of the crash cushions in India that we have done over the last few years. This is another one, and this is performance verified. So middle of the night, uh, it was a little foggy, and the whole family, 7 people, saved and verified by the maintenance company at the project. Now coming to crash barriers, I think we all know some of the side hazards, roadside hazards that it protects from is like a drop or trees or other or even medians, crossover accidents. So we are talking about performance tested, again, crash tested barriers. So conventional or material specified, and now we're talking about performance specified. Generally performance specified are engineered, well engineered products. They may be lighter than your conventional crash cushions, and um, I have a good slide to show the difference. So you can compare it, the conventional, as a heavy person who does not have much performance, but compared to Bruce Lee, who is lighter but can do the job. International and IRC standards, some of the standards here, so they're covered in all the standards, and the IRC 119 hopefully will have a new revision which will have more about these standards. I'm not going into details because of the time, but I have a lot to say. So generally we'll divide crash barriers into flexible, rigid and rigid. So flexible barriers are wire rope barriers. They offer the maximum deflection, and therefore if I was given a choice and to crash between a rigid, semi-rigid, flexible, I would rather let my car get into a wire rope barrier because it offers much less impact. Then, so these are some examples. So these are also crash tested. You can see it's tested with the bus. In India, again, we have to see that a lot of people on our roads, they are traveling, common man travels by roads. So we have to look at their safety also. So the barriers must be tested with a bus. There are some installation examples. So this is a wire rope. Sometimes people say, can it save? Yes, of course. So we had tested a bus earlier with a tri-beam, and now you can see a wire rope also. The only difference being that we need more space for deflection. There are some installation examples. You can see on the median, very, very well performance. You can see here that even after impact, the wires are still in place, the posts are down. And so that means the secondary impact can also be prevented, which is not the case with any other barrier. Here also you can see there is we could not see the vehicle because it had impacted and gone, no damage or very little damage, and even saved, a very large tractor trailer. And treatment. So these are the hazards. So wherever our barriers end, they need to be treated. They need to be protected. Otherwise, they cause such kind of accidents, and these are very common. Very recently, 20-year-old kids lost life in Delhi because someone tried to change the AC settings, and that was the moment it took the lives. This is not the picture from there. So this is how it looks. So these are energy absorbing, and these are also tested to perform. So you can see the difference in the performance. Then we have motorcycle protection system. As I said in the beginning, we'll be focusing on the safety of the two-wheeler or a motorized two-wheeler rider. So if you look here, this is very common. You have a two-wheeler rider, and on the curves usually. So what we see is that the posts below the barrier are major cause of injury and fatality in case of accidents with two-wheelers. So this is the solution where we place a softer beam below the existing. You can put it on any other tri-beam or W-beam that is there, and it will create a safety barrier for two-wheeler riders. And so this has been crash tested as per EN 1317. So bridges, again, a lot of accidents we know because the bridge parapets are there is no standard as in India. So you can build any kind of bridge barrier, and if you see, every now and then there will be a news about some or the other accident involving a crash where the bus or a car or something went down a bridge. So we need to have high performance barriers for bridges
These are high containment. You can test it for 38 ton articulated truck and also for a 900 kg car. So then we talk about median openable barriers. So they are, you can see here, many of them have been installed at Atul Setu, Mumbai. So you can create an opening in case of an emergency, or when there is a traffic jam on one side, you can create, or an emergency vehicle has to pass. So you can create this. Very easy to move, can be moved by 2 people only.
You have 2 more minutes.
Sure, sir. I'll try to wrap it up. The safety part. Now I talk about, the latest in NDT techniques for assessment of RCC structure, especially when it comes to roads. We're talking about bridges. We are NABL accredited. I am a council member here, visiting faculty to Indian Building Congress, etc., etc. I have been selected to ND Titans, which is an international group, and received an award for some work that we have done in India. We cover all range of types of structures. We have an experienced team. So if you look at this, SP40 is an IRC guideline for repair, strengthening, and rehabilitation of concrete bridges. So here they talk about all the latest tests, and we cover all of them. So we have the facility, we have the trained manpower, we have trained engineers and equipment in-house to do all the latest tests that have been specified in this standard for assessment of the condition of bridges. So so for strength, there's something called the pull-out test, a lock or capo pull-out test, where we crush a small part of concrete on site to get the compressive strength. The compressive strength with this is within 6 to 8%, and several papers, even in India, and studies have been done which have proven this. So we locate the reinforcement and do some process, and after that, we apply. I don't have the time to run the video, so this is a hydraulic pull machine which gives you the result directly, and this is the crushed part of concrete, and it holds the maximum value, and you can get this compressive strength of concrete. So these are the correlation. These are robust correlation. Does not depend on the type of cement, the aggregate mix, or any other water cement ratio, age, etc., etc., etc. To 40 millimeters, which is the case most of the cases. So this is a comparison of this test versus a core test versus the rebound hammer. So you can see a very good accuracy with this. So these are some projects on which our team has been working. Then for concrete homogeneity, we have pile integrity testing using a low strain integrity testing of pile for finding the defects in piles. We also have cross-hole sonic logging with 3D tomography, so we can give you exactly what's going on inside the pile. So these are some projects. And then crack depth and crack mapping. We also do crack monitoring. So if you have a crack that you need to see whether it is moving or not, what is the depth, what is the the thickness of the crack and depth, we can do that. Then for very large areas, we have the impulse response test, which allows us to do screening of very large areas. We can do tunnels, we can do bridge piers, and we can create a contour plot of the mobility which gives us the area. So if it is about repairs, it's a fantastic test to find which area need to be repaired, which are the areas deficit in some concrete integrity, and then after repairs, how good has been the repair. So you can reduce your repair cost substantially by using this test, pre and post repairs. So these are some of the projects. Cold joints. We have been use this test for detecting cold joints. Repair quality you can see here. So these are some. We even do it a lot on masonry structures, which no other entity test works. We've done this a lot. Then impact echo test, which is a confirmatory test for any defects. Find.
Please come
Sure. 2 minutes. So multiple reflections in a plate, and then we are able to find the depth or defect inside a slab to what depth is that defect, what application. And then the main application of this test is when we are building concrete bridges, post-tension bridges, then the ducts have to be grouted, and many times the ducts are not grouted, so you can have places of voids in ducts. So there is no other method that can tell the location of the voided ducts. We have done this on several bridges, and we have been able to locate found this thing, drill holes, put a endoscope inside and find the extent of damage in the tendon ducts there, and then either do a treatment or do an external, post tensioning for the repairs. So this is how it does it. Don't have the time for this, but it'll just give you an idea of what we're doing. There's several projects we've done. Then GPR for multiple layers of reinforcement, column beam junction where the conventional cover meters and rebar locators don't work. We can find out using GPR the reinforcement. Then tunnel assessment, corrosion assessment. So not only we find the half cell potential, we can tell you exactly how many millimeters or micrometers of reinforcement is deteriorating. So we can help you with service life estimations using this. And some recent projects. This is some bridges on Ganga. So we did AIMS. 34 buildings were done at the time of COVID without affecting any, operations in the hospital. This is Ludhiana Smart City. A lot of metro projects. We've also been involved in the high-speed rail project where we were invited to do tests. Tunnel projects. A lot of bridge projects. So that's all. So this is
Thank
my
you.
contact number. Invite you
Thank
to
you,
contact
Parampreet.
us for your, requirements for road safety and for condition assessment of bridges or any other RCC structures. My number is there. We are in Hall 1, Chitrakoot Hall, F21. You're very welcome. I'll be there for rest of the,
Thank you,
time.
Parampreet. Being a IRC council member, he's also one of our best resource person. When you draft any document and float in web, he's the first person to give his valuable input for the equipment assessment. And
Thank you very much, sir. Thank you for.
Thank you. Thank you. Now the next presentation is on from a Netherlands presentation. It is on latest development in PMB technology using vinyl polymers by Mr. Victor Gomes.
It's not you. It's not over. We don't know.
It is on the PMB technology, latest development in PMB technology. I'll request if you can finish within 8 minutes time. As we have 2 more presentations to follow. In fact, we started late, about half an hour because of previous session. And in between, we're losing time because of the change in laptop hanging up the system. But I'm trying to give full justice to the presenter here so that they can demonstrate that technology. ग्यारह presentation 22 मिनट जाता है. This is a session. I would request IRC event management team, at least in subsequent presentation after this one, check your system and all the presenter slides so that we'll not lose the time in between so much.
कौन सा वाला सर? 10 10 में तो है नहीं. नहीं. इसको लगाओ.
पहले इसको सेट कर दो.
वो तो खरीदना है. वो तो वैसा कोई पेटीएम साहब जो लैपटॉप एक्सचेंज करो, ये वहां ले जाओ, वो यहाँ
सुबह नहीं.
Interesting. It won't work.
लूज हो रहा है, केबल लूज हो रहा है. Cable loose, there is a loose connection.
We have also in the pen drive if you want to try in the other computer. On the other laptop. Yeah, Manfred.
तो ये पेन ड्राइव आप वहाँ से डाटा को ट्रांसफर करेंगे वहाँ से निकले मैसेज फोन की
I will request if you can finish within 7 minutes.
Yeah. Good afternoon, everybody. There goes 1 more minute of my presentation. I will try to speed up, but in case you want to discuss a little bit about bitumen modification, please stop by stall number 5, D5, and we can talk a little bit more. Today I will be talking about iVinyl SPS and why it is the best solution for modifying bitumen. Very quickly here, Creighton is an ex-Shell company that invented the styrene block of polymers in 1957. I want to highlight that also in 2010, the highly modified asphalt paving technology was adopted worldwide and is still a reference in terms of performance of polymer modified bitumens. In India, we started making efforts in 1992. And because I'm R&D, I want to highlight that in 2018 we opened a technology center, and that for me testifies the commitment that the company has to this country and to this region. As of today, our best seller in India, let's say it, the 1192 was already adopted by the major concessionaires. So very quickly on top, this is basically the mix that we drive on the road, but just by the individual components. It's up to scale, so you can see 5% of the bitumen is very little, but we put 5% of SPS polymer in 5% of bitumen, so we can almost miss it in the picture. It's very small amount, 0.2 to 0.25% of the total asphalt mix, and this creates a huge impact on the final performance of the product, extending its durability. It's a 1-minute video. It's very easy way. Image is stronger than words to see. This will be a stretchy bar of an unmodified bitumen. So you stretch it and it goes to a point that it cannot recover its shape anymore. And now we have the comparison with the polymer modified asphalt. First we do the blend in the lab. We drop the pellets. The high shear mill will reduce the size of the pellets. It's a relatively easy process. At the end, we confirm there is no polymer still there, so everything is dissolved. We can now make our stretchy bars and we can compare how does it behave compared to the unmodified binder. So it's tougher, more difficult to stretch, but what is more impressive and the reason why it's used is the ability to retrieve its initial form. So in terms of molecular design, we see here a typical molecular design of a linear tri-block with the 2 styrene blocks at the extremes. This gives the toughness to this material, and in the middle, the butadiene rubberized block. On the right, you can see that there are other designs like radial combinations of linear tri-block and di-block. And also on the center, we can see that when we do polymer design, we can vary some characteristics in order to get
what we want from the polymer. For example, polystyrene content, relatively molecular weight, block composition. So low vinyl versus high vinyl. We are here today to talk about high vinyl. Normally, when we produce SPS polymers, there is already a residual vinyl content in the material. So let's say about 10% vinyl. What we do at Creighton, we react further, we react in a different manner in order to create additional vinyl content. And when we talk about high vinyl, of course, we cannot disclaim what is the vinyl content, but we're talking about numbers above 30%. Very quickly, this one is for you to see the impact that the company has. So all the grades, SPS, hydrogenated grades, functionalized grades. You can see in the bottom all the applications, not only paving and roofing, personal care, medical, automotive, recycling. So we play in very different and distinct applications. I'm from all these grades, I'm highlighting here the 5 that are high vinyl. And I did a bit thicker box. I don't know if it is very noticeable. Of 1192, again, our bestseller in India, and 243, which is the polymer that we use to do the highly modified asphalt. So both are high vinyl. So you're using this technology is being used in India. In my opinion, the most important thing when we do polymer bitumen modification with SPS is the compatibility that the polymer has with bitumen. And these days, this is getting more and more difficult due to the bitumen quality. There's a storage stability test that you need to wait 1, 2, 3 days to see if indeed the blend is stable or not. But we at Creighton, we use UV microscopy to get an indication of that. Because we just get it 1 minute after. So we can do a blend, we take a droplet, we see it under the UV microscope, and we know if the blend is already stable or not. So you can see here from top left to bottom right, how does it goes when we add the polymer. So we start with a two-phase morphology, and we continue until we have an homogeneous blend at the end. Two very quick comparisons. On top, linear low vinyl SPS. On the bottom, equivalent to polymer but high vinyl. And you can already see that in the bottom it's completely homogeneous, and then in the top it's not. So it already shows that high vinyl is more compatible. A second example, more extreme. On the top, this is a perfect picture for incompatibility, so very bad. But on the bottom, I would say that we're very close to be homogeneous with only 1 hour mixing with the high vinyl SPS. Again, it's great for compatibility. And because it's very good in terms of compatibility, there are a lot of indirect effects. We can choose a wider base bitumen. So we can choose, for example, harder grades because this polymer, this type of polymer is more compatible. This polymer is also reactive. So we cross links already with temperature. So it makes the process go faster. So we might even use less crosslink or less sulfur when we do blends using high vinyl polymers. Because of these characteristics, it's also easier to meet MSCR specification and JNR different specifications. And because it's faster processing, we save energy because things are faster. And because it's faster, we also keep it less time at high temperature, so we have less emissions. It also has lower viscosity compared to low vinyl grades, which means that it is a much better fit for master batch production.
Please conclude.
Yeah. So here, very quickly then, 243, die block is the one that allows the widest base bitumen choice. Is super easy dissolving, super compatible. I don't remember a blend that failed using 243, and that's why it's a polymer the choice of highly modified asphalt. The 1192 is our workhorse, is the most used polymer in India. It's a bit bigger molecule than 243, but it is a very good combination of efficient cost and performance. And 1195 is a new polymer that we are developed. I will skip this one, but you can go by the stall, and if you are interested in using a bit less polymer and the same performance, we can talk about it. Very quickly, a lab test that we have that measure the torque while we're performing the blends, just to show you that the linear low vinyl polymer requires more torque, so more difficult to dissolve, and the two high vinyl polymers are much better in terms of dissolution. So I'm already talked about it. What are the benefits of using the 243 and the highly modified asphalt to reduce thickness up to 40%, enhanced durability, superior rutting and crack resisting, initial savings, and lower maintenance requirements. I will skip 1195 again.
Please conclude.
Pass by the stall and we can talk about it. If you're interested in CO2 emissions, we can also talk a little bit about it. And just to finalize something that we're very proud here, one award on the left that we got on IMA from 2019 here in India. Also a very nice picture from a world record that we also helped to achieve here in India. And on the right again, a little bit about 1192. And last slide, some QR codes. I recommend you to see the one in the left is a webinar from last month, very interesting. And the two pages on the right, you can see videos like the one I showed in the beginning. They're quite interesting. Thank you very much.
Thank you. Next presentation is road and civil design by Anil Subani. Affordable civil and road design. Please finish within 7 to 8 minutes time.
Yeah.
And focus on your design concept instead of introducing your company so much.
ये आपका ही है ना ये वही बात तो यहाँ कहाँ वहाँ पे रखा है कहाँ रखे पोटेंशियल सर कौन सा मतलब सिविल सर वहाँ से डिस्प्ले हो तो हाँ हो जाएगा सर ये बड़ा
A very good afternoon, everyone, and thank you for providing this opportunity to present our solutions in front of you. I'll not take 7 to 8 minutes, that's a promise. So, I basically represent a company called Brixis. So, we are coming from Hexagon, which is the subsidiary or the parent company of Brixis. So, Hexagon is into a lot of things, especially into software and hardware, wherein we provide solutions starting from total stations, digital reality captures, including satellite imageries, drone surveys, and also software solutions, especially for designs and also analysis in terms of crash testing analysis, structural analysis, etc. So this is just a video representing the design solutions that we have in terms of the CAD, what we provide. So I'll just play this video for your reference.
BricsCAD is computer-aided design software for people who build things. It's the best choice for drafters, designers, architects, and engineers. It's highly compatible with everything you already know. It's based on industry standard DWG for both 2D drafting and 3D modeling. BricsCAD leverages the power of artificial intelligence to help you work faster and more accurately. Hundreds of third-party applications run on BricsCAD to power your workflows. BricsCAD is a design platform that runs as one product, end-to-end. BricsCAD BIM is a unique CAD-accurate building information modeling system that keeps design first. BricsCAD Mechanical brings a familiar workflow to mechanical assembly design, and it works with BricsCAD BIM to enable the design and documentation of manufactured building products. No other CAD vendor can deliver on this promise. BricsCAD is cost-effective. A BricsCAD perpetual license is half the price of a yearly subscription to that other CAD program. Try BricsCAD today, free for 30 days at Brixis.
So what we have seen is we have seen a plethora of presentations, technically deep diving in a lot of things that happens on site But it's really important to understand what happens in the back office as well, especially with the design, because design is something that is included in most of the phases of construction, right from the bidding stage to planning to construction of maintenance part. So design kind of forms a very integral part. And then really when we speak of new technologies, with technologies comes cost, right? And it's really important for every one of us today present here to save costs wherever we can, right? So this is where an opportunity lies to save your cost on the software solutions that you have been using, wherein BricsCAD comes in handy not just in providing an alternate solutions to your current CAD environment, but also a solution that is much more smarter in a way wherein we have included certain algorithms that uses AI, right, to help your designers or users use in their workflows. So this is what BricsCAD is all about. As I mentioned earlier, we are a part of Hexagon AB, which is a 4.35 billion euro revenue technology group, and its product ranges right from hardware to software and many other uh, portfolios. And then in terms of number of users, we have 500,000 users actively using BricsCAD today. Even in India, we have about 15,000 plus users today using BricsCAD actively. We are headquartered in Belgium. We are an European company with about 300 plus employees working. So how easy it is to use BricsCAD? Pretty much easy. Even if I give anyone of you all the software today to work upon, you'd be very able to work on the software itself. So because we have all been exposed to a certain CAD software even during our engineering days. Speaking of that, once we know a CAD software, it's not difficult to learn BricsCAD at all, right? And speaking to which, let me just introduce my colleague Shubham to you, who will take you across the civil road design solutions that we have on top of software. So thanks.
Thank you, Amar. So my name is Shubham Vani. I'm an application engineer at Civil Survey Application, based in Jalgaon, Maharashtra. So the
Please
civil
be
survey.
loud. Please be loud and finish within 3 minutes.
Yeah. So I'll just start with basic software introductions video.
Design, the comprehensive and all-inclusive civil engineering software package built for your CAD platform. Civil Site Design is a multidiscipline software package which sits directly over your existing CAD platform. With integrated design and drafting, it includes a variety of modules for the design of a wide range of services and expertise. Using the grading tools allows you to model anything from detention ponds, car parks, and retaining walls. Undertake earthworks design with the inclusion of detailed reporting. Create combined models for volume analysis and documentation. The road design tools assist with the design of infrastructure, from the concept planning stage to detailed road design, allowing designers to quickly produce designs for road reconstruction, highways, rural roads, and subdivisions. Template creation forms the backbone of road design, allowing quick and accurate formation of the road shape, subgrade, and batters. The dynamic relationship of objects and views through the software mean that as objects are edited, line work and models all update. Conditional design can be incorporated to automatically change your design cross-sections to suit certain conditions. Pipes module has a fully integrated drainage design tool for the design of drainage, sewerage, and service and utility networks. The pipe module can work collaboratively between HECRAS, Watercom Drains, and AutoCAD Civil 3D. With the HECRAS module, you can combine the 2D flow modeling with your existing and proposed designs. The 3D Model Viewer provides a suite of tools to assist with design and analysis of projects. Undertake full 3D site distance analysis to check site visibility along highways or at intersections. Line marking tools allow you to create line work in the CAD environment and display in 3D, or send back the drawing as fully created markings. Share your 3D models through your web browser and social media, with the inclusion of virtual reality if desired. Civil site design is fully integrated with your CAD platform. Following any changes that are made to the design, the plotting and modeling outputs can be automatically updated without the need for extensive remodeling and drafting. Civil site design is an all-inclusive, easy-to-learn, cost-effective civil design solution.
Can you conclude?
So,
Time is over.
yeah. So, under the civil site design on the top of BricsCAD, we have the several features like rapid and interactive design processes. We have some automated tool creation for intersections, then called the SAICs, roundabouts, curve returns. Then we have some like real-time rendering review. If you are doing some 2D works in the under the CAD environment, you can visualize your drawing in the 3D. So we have include all IRC standards in terms with designing the highways. So if we are saying the what we have under the civil site design for the ISA standards, so we have super elevations, calculation sheets, then automated line marking tools as per the IRC guidelines. Then we have some plotting output for the NHI as well as IRC standards. Then we have some tools like you can also clash detection over here for the design. And we have also floor plan analysis. We can analyze this by HECRAS data. Then these are the output we can achieve by using our civil site design. So this kind of terrain, you're saying all the details has been designed under the civil site design, and we can model that kind of video for the documentation purpose or presentation purpose for the client. Okay. And if you are trying to more realistic video, so by using a third-party application Twinmotion, you can achieve this kind of output presentation. So these are all highway as well as roundabout, the corridor, line markings, as well as our terrain has been designed under the civil site design, and we can give a like a video output like this. So our software are using in other India. So these are the our clients are using in-house highway design team our software like BricsCAD as well as civil site design for the designing a highway. Then these are our licensing policy. We are licensing policy are very flexible. We have a permanent solution. We have to pay one time, as well as we have a subscription basis. So these are our license policies. And thank you for listening our
Okay,
presentation.
Thank you. Thank you.
Thank you.
Now, the
We
last
can contact.
presentation of this session is one of the important presentation on underwater retrofitting and strengthening of bridges. It's one of the very important topic of demand in our country. I would request the presenter, sir, again, if we can, 7 minutes time, though it's a very important topic.
Dinosaur. Next. आप सेव किया था ना उसमें? अच्छा
Mr. Rajesh Pandey is the presenter.
Hmm? Oh. Good afternoon, everybody. On behalf of Rajesh Pandey, I am Somudi Pramanik, presenting Dinosaur Concrete Treatment Private Limited. A little bit of our company, we are providing engineering and project management services to maintain the assets of road infrastructures like bridges, tunnels, subways, and viaducts. Our profile is from dam, hydros, bridges, tunnels, port and jetties, industry structures, and specialized underwater civil works. We are last 20 years old company providing all type of service to the PSUs like PWDs, railways, power generations, and other PSUs. Our services depends on starting from the NDT inspection, health study, then design of data, analysis of the evolution inspection reports, and then retrofitting and strengthening of engineering structures, leakage arresting, and solution of expansion joints and bearings. Now as we are discussing about underwater repairs, so I will not go further on the merits and what the demerits of the underwater strengthening and here, because this is all will take time little. But I can mention that underwater engineering or underwater works is a
a combine of the all the interdisciplinary nature is the hydraulics, mechanics, robotics, electronics, communication, construction technology. We have to take all the thing combination to do an effective repair in underwater. The main part factor is drivers. We have a lot experience, more than 200 drivers with us, so carry out these jobs. We have special equipments which are helping us to carry out these underwater works, and obviously the material is required now in now generation. There is very good materials available for underwater repairs, so that now the underwater repairs become more effective. Under repair methodology, first we start with inspection, evaluation, evaluation, then repair methodology and selection material, execution, and lastly the post treatment inspection. The survey part, obviously we will not go for, we go for level 1, level 2, level 3 inspection for that. And we also have a sonar technology we use in the turbid and low visibility areas. We get the mapping of the scour mapping of the VN piers like that with sonar technology. We carried out NDT above and underwater for the structure. Then we prepare a report and or the repair methodology and finalize with the clients. We first one go for a methodology where strengthening a well foundation by jacketing in underwater, where we found the well foundation has a lot of scour below. If you see this, the river bed is there, well is there, and when you underwent inspection, we found lot of scour underneath the well foundation. And then we do the shuttering for we do the inspection, then find the cavity part, and then we go the shuttering for micro concrete. We fill the cavity with micro concrete then, and then after that we do the underwater drilling for make the encasing of the well foundation, and then shuttering for jacketing, and then concrete with the self compacted concrete. The similar studies of the similar nature work we have carried out in Bilashpur, one of the railway bridges, where the if you see the plotting in the well was hanging almost, only the few part was on the soil part, other part was there was cover on that, and we have carried out this work in underwater. You can see the drilling of reinforcement, then shuttering, then concreting was carried out with pump system, encasing of concrete on there. The work was a very difficult job, and they have given a very stipulated time of 6 days. 46 we have completed in 44 days. Same way we have completed toll bridge in under PWD, Dadli bridge on the PWD, where the similar problem was there, and Godavari bridge in Maharashtra. Second part is that we are doing also the strengthening of pier by jacketing in underwater. You can see the pier where the jacketing has to be taken care. The repair methodology is there, where we have to do the under inspection, crack repair, and then drilling, and then anchor bar fixing, and then glass fiber reinforcement jacket we fix around as a shuttering, and then we pour epoxy or self concrete as per the specification. You can see the picture where we do the just symmetric pictures, where you can do the crack sealing, then fixing of steel bars, fixing of reinforcement, then glass fiber shuttering, and filling with epoxy or self concrete. Similar job we are carrying out presently in Obra Bridge, Uttar Pradesh. We have already carried out in Baitarna Bridge, Maharashtra. We are carrying out in Natravati Bridge, Karnataka. After that, it is a third point where cracks and cavity of repair in bridge in underwater condition. This is a normal repair where we found the well foundation or piles are in a deteriorated condition, or a lot of cracks are happened there. This is we found the underwater expression where we first do the surface preparation, then fixing of the nozzle on that, and after that nozzle we go for the sealing of that part of the cracks and after sealing we go for the grouting of that, we epoxy grouting on that. All are underwater setting material on that. So the case studies of the similar what we are doing in Brahmaputra Bridge in Gopalan, Assam. We are doing Saraighat Bridge, Assam, Naina Bridge, Uttar Pradesh. We have done. This is apart from our underwater works. We also carry out works in the above part, above water. We strengthening with carbon fiber reinforced polymer system. And lot of bridges we have done where we have increased the capacity and enhanced the capacity of the bridge and repair the normal cracks. And after that, there was no such cracks and appeared in after a few years. We include the visual inspection, NDT, and other monitoring. We do that, and we do the design and approve from the concerned authority. And then we application and post testing. So also we would check with vibration analysis and other analysis on that. Even pre and post load testing also is done for that. The similar case studies from the similar work we have done in Wardha Bridge, Maharashtra, Wardha Bridge River, Yuvala, Andari and Box Culvert in Muller. This is underpasses. Ranoli Bridge in Gujarat, Pratapnagar Bridge, and now recently complete Balaghat Bridge. Apart from them, it's a small video want to play actually. Sorry for वीडियो सेव नहीं किया हमने उसमें नहीं नहीं आई डोंट नो नहीं इसमें नहीं चल रहा है मेरा कुछ
फोन क्या प्रेजेंट किया ना गोयल नेक्स्ट उसके साथ कोई जॉन गोयल तो मेरे साइड क्या जॉन किया
a small video of underwater repair. We found the chainage first answer. This is the cavity you can see. Whole the whale was hanging. Cavity measurement shows there was 600, 650 height cavity was there. We fill the boulder on that first and then make a shuttering for micro concrete. Shuttering checking was done and then it was filling with micro concrete is being pumped to the pumping. This is all an underwater setting material. There we are drilling and fixing of anchors in the below the well foundation, so that well wall staining wall can be increased, so that future this type of cavity can be assured. We have done the shuttering for the concrete, and then concrete has been placed from the top with pumping up. You can see the settlement set of the concrete. All the concrete has been set. And post we have done 2 years. It is completed in 2018 actually, and after that on 3 years basis we are doing the we monitoring this one, and we have done underwater inspection, and we found it is absolutely okay. Thank you very much. Thank you,
Rajesh
for
Pandit,
presenting
for an excellent presentation,
Thank you.
and excellent case study. Thank you, Pandit. Now we have almost concluded about 11 excellent presentation, and we are lucky also. I have only one question from the audience. I will allow that, and then my co-chair will brief and will conclude. The question is about, I think, hot in place recycling. The question is, what is the existing surface is heated to how much temperature? And how does the HIP treatment compares with white topping?
Mr. Saigal is for you. आपके लिए
Please try to answer it within 2 minutes only. What is the temperature to which it is heated and how it is comparable to white topping?
Hello. Hello.
Hello.
Well, the temperature it's heated to is just under the softening point of.
bit louder. Your voice is not catching.
Hello.
This one.
It is heated to a temperature of about 147 150 degrees C. That is the road, and it's pretty much maintained there, so that you have the final pavement at about 135 degrees at the behind the paver, allowing you to finish the rolling by say 90 degrees or 100 degrees. That's part one.
How it is
Part
compared to
two-
white topping? How it is compared with white topping? That is the next
Yes,
question.
white topic. Yeah. Well, white topping is expected to last for 25 years. We think that as far as HIPR is concerned, we've been able to deliver 6 years as of now. Maybe we could probably go up to 8, but at this point in time, that's the level of technology.
I think the question would have been asked. The topic was is hot in place recycling. It is about how to reuse that with virgin. White topping is something different because we add white topping on an existing layer. It's not in cycle recycling. Okay, thank you, the audience. Now my co-chair will brief about this 11 presentation, then we'll conclude.
Well, good afternoon, my chair and all the eminent speakers sitting on the dais and the esteemed members of the IRC. We have 11 numbers of very excellent presentation. I will quickly sum up the presentation. Number one is epoxy asphalt modified binder by Mr. Mridul Goel and Mr. John. They talked about most durable binder, which is much needed in our country. And that is two component chemical system and thermoset polymer modified asphalt. And they have concluded the presentation with a nice video of the Mumbai Pune expressway case studies. Second one is about the automated road condition assessment by Mr. Clint Bradley. That is operated with a life of 10 years, which is very, very relevant. It should not be, and it is very relevant and needed, especially for the hill roads. Fourth one is about reinforced soil technology in the tunnel portal platform construction by Mr. Atanu Adhikari. Case study he talked about a case study in very nice, interesting case study in Jammu and Kashmir. It is a sustainable solution. Stabilization of the critical hill slope he has talked about. And lastly, most very important and interesting word he has said, it is to balance in between the hill and the valley side. We should not cut the hills. So that is very, very relevant question from environment point of view. The fifth one is on the road infrastructure and data utilization, measurement and data collection by Mr. Richard Wixping. He talked about how the consistent data capturing and measuring that is required. It is very important. Sixth one is about the hot in place recycling by Mr. H.K. Saigal of Topple, India. Case studies of many NHS project he has talked about and how much bitumen consumption can be saved, and he has also shown how much saving in the carbon emission could be done, and also in the natural resources. So it is very, very sustainable point of view. From sustainable point of view, it is very good technology. Structural and functional advantage has also been discussed in this presentation. Seventh one is the stabilization technology using the stable road additive by Mr. Krishna Ramela. He talked about the soil stabilization and FDR technology. Talked about the application of the technology in the area of the high rainfall area and other challenging areas also. He talked about ecological benefits and some case studies shown, and concluded with a nice video of the case studies. Number 8 is the advancement in the road safety and NDT techniques of the concrete bridges by Mr. Paramprit Singh of Avantec Engineering Consortium Private Limited. Nice videos of the crush test he has shown, and with the videos he has explained the purpose of the road safety items. That is very good, and because of the time pressure we could not see much of the NDT techniques which is actually he has explained for the concrete bridges. Number 9 is the latest development in the PMB technologies, high vinyl SBS polymer by Mr. Vitor Gomez. He explained the functioning of the low vinyl versus the high vinyl, and also explained how it is designed for the high performance. Number 10 is a affordable civil and road design solution by Shuham Anil Wani. Bricks, CAD and civil site design. By animation videos, he has demonstrated how the software functions.
And the last one is underwater retrofitting and strengthening of the bridges by Rajesh Pandey. It is a very nice presentation of the case studies, showing the case studies. He talked about methodology of the very critical engineering requirement of retrofitting different underwater components of the bridge, shown some very good photographs of the case studies, and at the last he has concluded with a very nice video of the case study. Thank you.
Thank you. Thank you, Co-Chairman Rajiv Chatraj, Chief National Highway West Bengal. I thank IRC and the audience and distinguished delegates for their patience to listen in the presentation. We are concluding, but with a request that most of the vendors are open their stall. Whoever have something to discuss and see their demonstration, equipment, technology, try to spend time more with them because these are the technology we have to use in our country. Thanks all. Thank the IRC for giving the opportunity to chair and co-chair. I thank all the presenter put their time and also supported us in presenting, adjusting with their time. Thank you all.
Thank you, Logan.
Now to the organizer to follow up with the further needful
Formalities.
formalities.
थैंक यू सो मच सर। बस 2 मिनट आपका और चाहेंगे थोड़ा सा उसे। और अब इस सेशन की समाप्ति के साथ ही एक छोटी सी भेंट आपको छत्तीसगढ़ की तरफ से, छत्तीसगढ़ पीडब्ल्यूडी की तरफ से देना है। इसके लिए मैं इनवाइट करना चाहूंगी श्री BS बघेल जी को मंच पर कि वो यहाँ आए, स्मृति चिन्ह और बुके से हमारे मेहमानों का धन्यवाद ज्ञापित करें। और हमारे चेयरमैन सर डॉक्टर NC पाल और साथ ही साथ को चेयर श्री राजीव छतराज जी का मोमेंटो के साथ धन्यवाद आभार व्यक्त करेंगे। Chairman Dr. NC Pal, former ENC Works Department Odisha, जिनका स्वागत करें श्री BS बघेल जी, चीफ इंजीनियर PWD दुर्ग छत्तीसगढ़। हमारे को-चेयर श्री राजीव छतराज जी का भी स्वागत, आभार और एक छोटे सा मोमेंटो के साथ धन्यवाद ज्ञापित करते हुए श्री BS बघेल जी। थैंक यू सर। और बघेल सर आपका भी बहुत शुक्रिया। साथ ही मैं इनवाइट करना चाहूंगी मंच पर मिस्टर HR ध्रुव जी को, सुपरिटेंडिंग इंजीनियर दुर्ग छत्तीसगढ़। साथ ही साथ मैं बुलाना चाहूंगी श्री ML उल्के जी को, SE PWD रायगढ़ से हमारे साथ हैं। सर मंच पर आ जाइए और हमारे बाकी जो मेहमान हैं उनके स्वागत के लिए सबसे पहले मैं रिक्वेस्ट करूंगी मिस्टर मृदुल गोयल जी से कि वे यहाँ मंच के सामने आए और स्मृति चिन्ह और बुके प्राप्त करें। सर आप भी साथ में मैं बुलाना चाहूंगी मिस्टर क्लिंट ब्रैडली जी को कि वो आए और आभार ज्ञापित करते हुए उइके जी और ध्रुव जी इस वक्त मंच पर मौजूद हैं। मिस्टर क्लिंट ब्रैडली, ग्लोबल बिजनेस डेवलपमेंट मैनेजर। मैं बुलाना चाहूंगी मिस्टर रजनीश नाथ जी को, मिस्टर रजनीश नाथ जी जियोबेक इंडिया प्राइवेट लिमिटेड गुड़गांव से हमारे बीच उपस्थित हैं। मिस्टर अंतानु अधिकारी जी, चीफ डेवलपमेंट ऑफिसर रेनफोर्स्ड अर्थ इंडिया प्राइवेट लिमिटेड न्यू दिल्ली से हमारे बीच हैं। नेक्स्ट जनरेशन टेक्नोलॉजी से मैं मिस्टर रिचर्ड विक्सबैंक को आमंत्रित करना चाहूंगी कि एक छोटी सी भेंट छत्तीसगढ़ी परंपरा, संस्कृति और वहाँ की लोक परंपरा को जाहिर करता ये मोमेंटो। Mr. Richard Wixline. Next Generation Technology Road Infrastructure and Data Utilization. इंडियन रोड सर्वे एंड मैनेजमेंट प्राइवेट लिमिटेड, बहुत बहुत आभार, धन्यवाद वक्त देने के लिए, वक्त साझा करने के लिए, और हिंदुस्तान में आपका स्वागत है सर। साथ ही साथ मैं इनवाइट करना चाहूंगी मिस्टर H.K. सहगल जी को, चीफ ऑपरेशंस TERPL इंडिया प्राइवेट लिमिटेड बेंगलोर से हमारे बीच मौजूद हैं। मेरा आग्रह है इसके बाद मिस्टर कृष्णा रेमिला जी से, डायरेक्टर इको एडिटपीस विश्व समुद्र इंजीनियरिंग प्राइवेट लिमिटेड हैदराबाद से हमें अपना महत्वपूर्ण समय दे रहे हैं। मिस्टर कृष्णा रेमिला। इसके बाद मैं बुलाना चाहूंगी मिस्टर परमप्रीत सिंह अर्नेजा जी को, डायरेक्टर एवेंटिक इंजीनियरिंग मेरा आग्रह है मिस्टर विटर जॉम से, जो कि नीदरलैंड से हमारे बीच पधारे हुए हैं। बहुत बहुत धन्यवाद। लेटेस्ट डेवलपमेंट इन PMP टेक्नोलॉजी और मिस्टर विटर जॉम्स। इसके बाद मेरा आग्रह है मिस्टर शुभम अनिल वानी जी से कि वो मंच पर आए और अपना मोमेंटो प्राप्त करें। मिस्टर शुभम अनिल वानी। मेरा आग्रह है मिस्टर राजेश पांडे जी से भी, डायनासोर कॉन्क्रीट ट्रीटमेंट प्राइवेट लिमिटेड वाराणसी से हमारे बीच मौजूद हैं।
one more. पांडे जी को कैसे छोड़ देते हैं? ऑलरेटर काम करते हैं, क्रोकोडाइल के नीचे अंदर पानी में। One more. ये पानी के अंदर है ना, इनको दिखाई नहीं दे रहा ना, पानी को ऊपर है ना।
थैंक यू सो मच। आप सभी का बहुत बहुत धन्यवाद हमारे साथ वक्त साझा करने के लिए, वक्त देने के लिए, बहुत शुक्रिया। और अब लंच टाइम तो कुछ ज्यादा ही हो गया, you know। इसके बाद हम अपने अगले पड़ाव की तरफ बढ़ेंगे, मतलब नेक्स्ट सेशन की तरफ। तो वो 10 से 15 मिनट के बाद हम उसे शुरू करेंगे। तब तक के लिए थैंक यू सो मच।